Today we're going to look at solving a basic kinematic problem. Once again, I will stress, do not focus on solving these types of problems. You do need to know how to do them, but remember, key conceptual understanding and interpreting graphs is much more important than being able to solve a bunch of math problems. So we'll look at a general setup, and this is a pretty easy problem, but I want to go through the steps of how to solve it. So the first thing is I like to use the G.U.E.S.S method, or sometimes we'll call it a P-G.U.E.S.S method. Generally, it helps first to draw a picture, but if you don't like to draw a picture, sometimes that's not going to be too much of an issue. However, some problems it definitely helps. So a rock is dropped off of a cliff. I understand the rock is dropped off a cliff. I don't really need to draw a picture to represent that. So we're going to start with our G.U.E.S.S method, which is writing our givens down. That's what the G stands for. It's an acronym. So what are our givens? Well, we read through the question and see what's listed. So the rock is dropped from rest. That's the first thing that I see here. So from rest means that its starting velocity is 0. So I'm going to write my initial velocity, Vy, not y, because we're in the vertical direction, not the x direction, equals 0 meters per second. You do need to write down your givens. Make sure you show all of your work on these types of problems. Off of a 24-meter high cliff. So 24-meter high cliff would be my next given here. So that would be, let's see if I can get this from changing. That would be my height, my change in height. I could write an initial height is 0 and a final height is 24 or something like that, but we'll keep it simple and write my change in position. I know we're going from the top to the bottom, so my change in position will be 24 meters. And that's just how long does it take to hit the ground, so that's an unknown, but because it's being dropped, we do have one more given value, and that is the acceleration due to gravity. So we'll say g, which we can write usually if we're talking about gravity, or you could write ay if you prefer, and we'll use 9.8 meters per second squared. So those are our three given values. The next thing we're going to look at is what's our unknown. That's what the U here is going to stand for. What are we trying to solve for? Well, we're asked how long. Not how long in distance, how long does it take to hit the ground, so that's the time. So our time is going to be our unknown. For your kinematic problems, you'll almost always have 3 givens and 1 unknown. If you only have 2 givens and 2 unknowns, you're not going to be able to solve it using a standard kinematic equation. So 3 givens, we're good, and 1 unknown. Now we need to look at our formula sheet and see which formula can we use. Which formula has initial velocity, change in height, acceleration, and time, meaning we don't have a final velocity here. And you'll see that the second kinematic listed is going to be the one to use. So the next one we'll write is our equation. Now just write out the equation fully. Don't rearrange it at all. Just your standard equation, which is my change in y is initial velocity times time, Vy not t, plus 1/2 at squared, right? Acceleration times time squared, but I know it's free fall, so I could write gt squared if I wanted to. There's nothing wrong with that. Now, a lot of people's tendency is going to be to immediately plug in your numbers here and start solving, start rearranging, simplify 1/2 g maybe, remove a few things. But it's important to know that throughout this course, you're going to be asked to rearrange equations without using numbers, just leaving it in this form. So I would say just right up from the beginning, don't plug in your numbers until the end, although it may make it easier for you now. A lot of times you won't be given numbers, and so if you have practice rearranging the equation in an equation form, it's really going to help you out in the long run. We can simplify it a little bit, though, because I know my initial velocity here is 0, so that means that this section, we can just remove that. 0 times time is 0, so we can remove that. It's G.U.E.S.S. So the next part of the equation, we're just going to really rearrange this equation, and we want to isolate time. We want to remove everything else from the equation. So we have right now delta y equals 1/2 gt squared. This is just some basic algebra. If you're still struggling with rearranging an equation, you really need to practice that. It's not going to be a heavily tested idea, but it's expected that you understand how to solve from t from here. So we'll go through it anyways. We'll multiply 2 by both sides to get rid of the 1/2, and divide by g to get rid of the g on this side. Those cross out. Those cross out. Now we have 2 delta y divided by gravity equals t squared. To get rid of the square, we'll make sure to take a square root of both sides. and we get square root of 2 delta y divided by g equals our time. Now we can do the last two steps, which is substitute and solve. Substitute is simply plugging in our numbers, and solve is what do we get in our calculator. So square root of 2 delta y was 24 divided by g, which is 9.8. And so our last S is solve, which says time is going to be, and it comes out to about 2.21 seconds. That would be my answer. Do not leave your answer in fractional form. You don't need to worry too much about sig figs either. Rounding to the 100th place is perfectly fine, perfectly acceptable. 9.8 is not even the most precise measurement for gravity, so as long as you get a close enough value, that'll be fine. The AP test does not worry about sig figs or anything of that nature. Just as long as you don't do a calculator dump, putting in 10 digits past the decimal place or anything like that, you'll be fine. So that's solving a standard problem. Make sure you know how to do it, but once again, don't focus on it. Start by writing down your givens, finding your unknown, rearranging your equation, plugging in, and solve. Know that a lot of times this will be your final answer here. You won't have any numbers, and you'll ask to write solve for time in terms of height and gravity, or something along the lines of that. Thanks for tuning in, and that's all.